We are going to be talking about the signs of the trig ratios of any trig function. So when we're looking at whether we say sine is positive, we're saying that the trig ratio is positive. So anytime it's not the angle that we're talking about, so we're not talking about the angle being positive or negative, that's only in the direction that the angle is being made. But if we say that sine is positive in the fourth quadrant, or if sine is positive in the second quadrant, we're saying that the trig ratio is the one that's going to be positive. So make sure that you understand that. So when we're looking at this here, we have where we say all students take CAT, and all that means that they're all going to be positive. All the trig ratios are positive in quadrant 1. And then when we say students is going to represent sine as positive, and therefore it's reciprocal, and so that's the cosecant, and so those are going to be positive. Everything else is going to be negative, so these are going to be negative, and these are going to be negative. And then when we say tangent, that means that the tangent is going to be positive, and therefore the reciprocal is going to be positive. Everything else is going to be negative. And then CAT, cosine is going to be positive, and therefore it's reciprocal, and everything else is going to be negative. So when we're looking at this and we're trying to answer this question where it says, indicate the quadrant in which the terminal side of theta must lie in order for cosine to be negative and sine to be positive. So I am going to erase all this. And what that's actually saying is that when we're looking at sine, the trig ratio is going to be negative here, and it's going to be positive there. So we want to know, and it's when it says terminal side, we're always assuming that it's going to start at the standard position angle, which is always going to start at the positive x-axis. So it's a standard position angle with the terminal side. Where is that angle going to fall in? So when I look at this, when the trig ratio is going to be negative for cosine, then we're saying that it's going to be the x values, and therefore it's going to be over here somewhere. So I know that cosine is going to be negative here, and cosine is going to be negative there. I don't care about any of the other signs. That's what that one is saying. And then the sine of theta is positive, so that's the y value, so it's going to be over here. So sine is going to be positive in this quadrant, and it's going to be positive in that quadrant. We want them both to be true. So we want cosine's trig ratio to be negative and sine's trig ratio to be positive. That is only happening in quadrant 2. That means that theta must be in quadrant 2. Okay, and then indicate the quadrant in which the terminal side of theta must lie in order for the secant and the cosecant to both be negative. So we want them both to be negative. Well, secant and cosecant are the same thing as sine and cosine. They're just reciprocals, but they're going to share the same sign for the trig ratio. So secant corresponds to cosine of theta, and cosecant represents the sine of theta. Okay, so that's going to be sine of theta. So when I'm looking at this, cosine is going to be negative. It's going to be right here. So this is going to be negative here because that's the negative x-axis, and cosine is going to be negative here. Therefore, that means that the secant is going to be negative there, and the secant is also going to be negative there. Sine is also wants to be negative, so that means that it's going to be below here. So sine is negative here, and sine is negative there. Therefore, the cosecant is going to be negative there, and the cosecant is going to be negative there. So where are they both? That's going to be in the third quadrant. So this means that the angle is going to fall in the third quadrant. Okay. So if the tangent of theta is equal to 1/2, and the terminal side lies in the third quadrant, find the secant of theta. Okay, so now here the 1/2 represents a triangle. And so we're going to form a reference angle because we're going to use theta to be a reference angle, and that's what's going to help us. So when I'm looking here at the 1/2, and I want the terminal side to lie in quadrant 3, so that means that I am going to form a reference angle right there. This is my reference angle and the reference triangle, and so that's this angle right there. Now tangent of theta is going to be opposite over adjacent because it's the two legs. The trig ratio ratios are formed from the two legs. So this leg right here is going to be 1 because it's the opposite, and this is going to be 2 because that's the adjacent. Opposite over adjacent. Now, because this here is in the third quadrant, I know that this length here, the y values are negative, so this is going to be negative, and the x values are negative, so this is also going to be negative. So I know that these two are going to be negative. The legs are always the ones that are going to be either positive or negative. The hypotenuse will always be positive, because when you do the Pythagorean theorem, you're always going to get leg squared plus leg squared, which makes them positive when I square them, and therefore this side here is going to be always positive. It's equal to the hypotenuse squared. So when I'm looking for this, I am going to do, because I need to find this side right here, because the secant of theta is the same thing as the cosine of theta. Cosine of theta is going to be adjacent over hypotenuse, so therefore secant of theta is going to be hypotenuse over adjacent. And so I need to know the hypotenuse. So the hypotenuse is going to be leg squared, which is 1 squared plus negative 2 squared, and that is going to give us the hypotenuse squared. And when you solve it, it's going to be 1 squared plus 2 squared is going to give us 5, so it's going to end up being the square root of 5. It's actually plus or minus the square root of 5 because we're talking about a distance. We're not going to be talking about the negative, and so the negative is going to go away, and it's just positive, because we also said that this one here was going to be positive. So when we're looking at this here, that's going to be the square root of 5. So the secant of theta is going to be the hypotenuse, the square root of 5 over the adjacent, which is negative 2, which makes sense that it's going to be negative because cosine is negative. All students take CAT. This is going to be, the trig ratios are going to be negative in the third quadrant, and that is your answer. Very good. And then when we're looking here, we're talking about quadrantal angles. This is not a coordinate axis. This is just separating them from 0 degrees, 90 degrees, 180 degrees, and 270. These are all quadrantal angles. The quadrantal angles are always the ones that are going to fall on the x-axis. So this here is a quadrantal angle of 0 degrees. This one here is a quadrantal angle of 90 degrees. This one here is a quadrantal angle of 180 degrees, and this here is a quadrantal angle of 270 degrees. So those quadrantal angles is what we're filling these in. And the main thing is that 0 and 90 degrees, those two quadrantal angles, we could do it with our left hand. So if I'm doing the left hand of sine of 0, there are 0 fingers below, so the sine of 0 degrees is going to be 0. So therefore the cosecant is going to be 1 over 0, and so it's going to be an asymptote. The cosine of 0 is going to be above, so that's going to give you 1. And not to mention that you can look at these. These are ordered pairs as 1, 0. This ordered pair is going to be 0, 1. And then we know that this one here is going to be negative 1, 0. They're the same, but this one's negative because this one's in the negative direction. This is still a length of 1. This is still a length of 1 because the ray, what it's doing, it's spinning around. So this is the same thing as a ray spinning around here. And so this one here is 0, negative 1. So the when you're looking at this and you're filling this in, you know that the cosine is going to be of 0 degrees is going to be a length of 1. The secant, therefore, is also going to be 1 over 1, which is 1. The tangent of this one here, if you do the left-hand rule and you flip it over, you're going to get 0 fingers above. Therefore, this is going to be 0. And then this one's going to be 1 over 0, which is going to be an asymptote. Once you know 0, you are also going to know, if I know 0 right here, if I know this 0 right there, then if I know this right here, then I'm also going to know this one right over here, because all you're doing is the same thing, just going to be negative. So if I could fill this in, I know that this one here is going to be 0, because that's what we have here. This one's going to be negative 1. This one here is going to be 0. This one's still going to be an asymptote, because when you flip this over, it's going to be 0. This one's going to be negative 1, and this one here is also going to be an asymptote. So the 0 and the 180, they're pretty much the same. It's just going to be negative because the sign switch is there. Now that's also going to happen with the 90 and the 270. The 90 is going to be, the sign is going to be, when you're looking at it, it's going to be 1, and therefore this is going to be 1. The cosine is going to be 0. This 1 is going to be 1 over 0, so it's going to be an asymptote. The tangent is going to be, now if I look at that, the tangent's going to be the asymptote now, because it's 1 over 0, and this one's going to be just 0. And then whatever happens here is also going to happen over there. So if I'm looking at this one here, that's going to be -1, because they're the same, but they're just a little bit different there. Oops, I don't know what I touched there. I apologize about that. Oh, it closed out. That wasn't my fault. Okay, so then this one here is going to be -1. This one here is going to be -1. This one here is still going to be 0. This is the asymptote. This one, better erase that. That's the asymptote. And this one here is going to be the asymptote, and then this one here is going to be 0. So just so that you know, if you know 90, which you could do with your left hand, you know 270. If you know 0, then because you could do it with your left hand, you also know 180. And those are the quadrantal angles. They're the ones that fall on the x and y axes. So how would you tie in the quadrantal angles to the first quadrant? Therefore, your left hand rule, we just talked about it right up there. So very good there. And then what is the sine of -270 degrees? Well, what is it asking for? Is this asking us for a reference angle? Is this asking us for to make an angle? What is this asking us for? And the main thing you need to know is that we have a trig function right there. So this here is your trig function. This here is your angle. So the only thing that's missing right there is your, yep, you said it, the trig ratio. So we're missing the trig ratio there. And this here is a negative angle, so we're going in the negative direction. So we're going to start at the standard position right there, and we're going -270, so we're going all the way over here. This here is -270 degrees, which ends up being also a quadrantal angle. This order pair is going to be 1, 0. So what is the sine of -270? So that's what we're answering right there. And the answer is going to be just 1. So the length of that is going to be 1. So it's not asking you for the radians. It's not asking you for a degree. It's asking you for the trig ratio. And in this case here, negative there is going to be 1. Okay, very good.